Okay, so we're going to do a review of Assessment 2 for Mod 1 in our 7th grade Eureka Math Squared. Alright, so this is our review. Alright, let's get right into it. Ava's dad gives her $8 a week each Saturday as a weekly allowance. Which equation represents the number of dollars, D, Ava receives as allowance during W weeks? So let's do what we always do. We're going to set up our XY chart. Let's make this a little bit longer. And in this case, our X is going to equal W. Our Y is going to equal our D. So every week, which means once a week, her dad gives her $8 just for living. So if she lives 2 weeks, she'll get $16. 3 weeks, she'll get $24, so on and so forth. So what does this mean? This, let's differentiate a little bit. This part here becomes our rate, our unit rate. So that means that 1 times 8 will give us 8. 2 times 8 will give us 16. 3 times 8, 24, so on and so forth. So our rate is 8. So in this case, D will equal whatever's on W times 8. W times 8. The better way to denote that is D equals 8W, which is right over here. Got it? So answer to number 1 was D. Alright, Sean makes his own barbecue sauce. Alright, Sean. His recipe calls for half a teaspoon of pepper and 3/8 teaspoon of mustard. Sean decides to scale his recipe up. He uses 1 teaspoon of pepper. How many teaspoons of mustard should Sean use to make his secret barbecue sauce? Alright, we're going to do this as a proportion. So he starts off with a half a teaspoon of pepper, and 3/8 teaspoon of mustard. So now we want to get that 1/2 to a whole. 1 teaspoon of pepper. Alright, so the question becomes, a half times what number will give us 1? 1/2 times what will give us 1? If you don't know, just as a rule, a fraction times its reciprocal will always give you 1, meaning 1/2 times 2/1 will give us 1, because 2 times 1 is 2, 2 times 1 is 2. We'll always end up with a whole number. If you wanted to check that, you would do, this becomes our X, that's not an X, this becomes our Y. You would do Y divided by X, which is 1 divided by 1/2. Use our keep change flip, Kentucky Chicken Fried, 1 times 2/1. 1 times 2 is 2. 1 times 1 is 1, still equals 2, which gives us our rate. This becomes our rate here. So 1/2 times 2, or 2/1, same thing, equals 1. So we're going to do that to the mustard. 3/8 times 2/1. Let's do it over here. 3/8 times 2/1. If you know anything about Professor Woods, he does not like big fractions. So we're going to reduce. 2 goes into 2 once, 2 goes into 8 4 times. That brings us to 3 times 1 is 3. 4 times 1 is 4. Our answer is 3/4 of a teaspoon of mustard. Alright, let's put our answer in our box. And we move on. Alright, determine whether each of the following relationships is proportional or not. Y equals X. That means our rate is 1. Yes, it's proportional. Y equals X minus 4. That is not proportional because this becomes a constant, gets in our way, changes X up a little bit. So no, not proportional. I don't like it. Get it up out of here. Alright, in our next one, we have to first thing we're going to do is look for the unit rate, which means we're going to look for the part that has 1 in it. And why is that? Because it makes it easier for us to find the rate. Here, 1 times 0.375. Let's make it bigger. Ooh, look at that. 1 times 0.375 is 0.375. So now let's test this theory again. 2 times 0.375. Bring up our calculator. Let's see if this is correct. Where's all this nonsense? 2 times 0.375 equals 0.75. Check. All right. Just for good measure, let's do it again. I don't know. I'm not very, I don't believe everything. So 3 times 0.375 checks out again. So I'm going to go out on a limb and say yes, this one's proportional. Again, with this next one that's up, I'm going to go to the one that has a 1 in it, go to the unit rate, and see if everything matches up. So this says the rate is 6. 1 times 6 is 6. So let's go to a half. A half times 6, I already know. A half of 6 is 3. So that doesn't check out. All right, so let's go over to 1.5 now. So now we're going to do 1.5 times 6. You know, we can do it on paper, but let's not waste time. 1.5, which is 1.5 times 6 equals 9. That still doesn't check out. So that's wrong. That's wrong. We're going to give this a big old wrong. So moving on is to the next one. So is this proportional? See right here. No, it's not. It has to go through 0 in order to be proportional. So that's a no. Is this one proportional? No, it's not. It has to be straight, not curved. So that again is no. Get it up. Oops. Get it up out of here. I don't like it. What letter was that? Lily finishes her 800-meter run in 2.8 minutes. Maya finishes her 1,500 or 1,500-meter run in 5.21 minutes. Fill in blanks to make the statement true. Blank runs at a faster pace. Let's see who runs faster. All right, so I'm going to set this up as a proportion. That's how I want to do this. We're going to do 800. I'm going to put the M over here to not get in our way for meters. 2.8 minutes. Minutes. Alright, I want to know how fast she runs. How far she runs in 1 minute. To get from 2.8 to 1, I'm going to divide by 2.8. What you do to the bottom, you do to the top. So I'm going to divide by 2.8. 800 divided by 2.8. Let's do it. Clear this up. 800 divided by 2.8 equals. So I'm not going to write all of that, but I am going to write up to the hundredths place. So this is 285.71. Let me look at it again just to make sure. 285.71, and now it says 1 because that's a 4. It doesn't round up. All right. So I'm going to put Lil right here. All right, we're going to do Maya in a different blue because Maya likes to be different. She doesn't want to be confused with Lil. Maya. All right, Maya runs 1,500 meters in 5.21 minutes. How many meters does she run in 1 minute? We are going to divide by what? 5.21. If you do it to the bottom, you do it to the top. 5.21 divided by 5.21. Put the point there so I can see it. Equals 1,500 divided by 5.21. Let's do it. 1,500 divided by 5.21 equals 2.8790. 287.90. All right, so looking at this, who runs faster? In 1 minute, Lil runs 285 meters, 285.71 meters in a minute. Maya runs 287.90 meters in 1 minute. She edges us out by about 2 meters right here. So we're going to say Maya runs faster. Oops, that ain't even Maya's color. Get that out of here. Maya don't like it. She wants her color. It must be too early in the morning. Alright, so Lily and Maya run at their constant paces for 1 minute. We just did that. What is the difference? Ooh. Let me stop using Maya's color before she starts yelling at me. Alright, what is the difference? What does difference mean? Difference means subtract. To the nearest tenth. Where's tenth? Where's the 10th column? 10th is dimes. So dimes is 1 space after the decimal. This is your 10th column, and it's dimes, right? To the in the distance they run. So that was, you guys know what we do. We annotate as we go. Give ourselves the answers. All right, fill in the blanks to make the statement true. One runs faster than the other. Somebody runs something less meters in 1 minute than the other runner. So who runs less? Oh, they were trying to trick us. They tried to get us. But we're ungettable. In 1 minute. So who runs less? So first thing we have to do is this. We have to find the difference. What exactly is the difference? So we got 287.90 minus 285. Oops, that's not an 8. 5.71. 90 minus 71 is 19. 7 minus 5 is 2. These cancel out each other, so we're at 2 19. But they ask us to round to the 10th, which is right here. Is this a 5 or higher? 9 is, so that means that one goes up. Our answer is Lily runs 2.2 meters less in 1 minute than Maya. And we said that earlier. I said it as Maya runs faster, but they're saying it as Lil runs slower. Does that make sense to everyone? Lily runs 2.2 meters less in 1 minute than Maya. Come on, Lil. Get that up. Work it out. Stop hanging out with Amber all night. All right, a party supply store rents bounce houses to customers by the half day. Whew, that's a long rental. The rental cost is based on the length of time the bounce house is rented. The graph shows the cost of 5 bounce house rentals. The relationship between time and rental cost is proportional. All right, they're telling us it's proportional right here. So that is not a question. Do not answer this as yes, it is proportional. They already told us that it's proportional. They told us they rent it out for half of a day, which is 12 hours. I don't know if I'll need that later or not, but I'm going to put it up there just in case. And we know that it's proportional, and they're doing 5 different bounce houses. All right, let's see what we got. Complete the table by using the times and rental costs from the graph. So for one half a day's time, how much does this cost? All right, according to this graph, 1 half day equals 50. Why does that look off? 2 would be 100. Oh, wait a minute. Look at this. They tried to get us. When you look at this, all right. Now, if you're doing this as a test or as a homework, I definitely would have had to give some points for the people that thought this actually measured up to 50. It doesn't. It measures up to less than 50. But by how much? Here's what I would suggest. Let's find one that is directly on, like this. So 5 hours is 200. What is directly in between 200 and 250? That would have to be 225. 50, 50, 50. Yeah, it's right on. It must be 225. These are dollars. Alright, so for 5 hours at $225, how much is 1 hour? So we're going to do 225. How do I get from 5 to 5? Divided by 5 equals 1. 225, what you do to the top, you do to the bottom. 225 divided by 5. Let's get our trusty calculator. 225 divided by 5 equals 45. So they wanted you guys to figure out that this number here was 45. That was tricky. I hope y'all didn't fall for the banana in the tailpipe, but we figured it out. Alright, so that means our rate is 45. Let's move this up. Now, for those of you that are in my class, you know how we do it. On the left side is multiplication. 1 times 45 equals 45. But on this side, going in this direction, it's division. Meaning 45 divided by 45 equals 1. Let's put that theory to work. We got 45 going all the way down. This is our rate. 90 divided by 45 equals what? Just in case you didn't understand how or what I said this is the direction you're supposed to put it in the calculator. 90 divided by 45 equals 2. Got me? So this is 2. 225 divided by 45. We did that earlier. Here it is. 225 divided by 5 is 45. So 225 divided by 45 is 5. 8 times 45 equals 8 times 45 is 360. 450 divided by 45 equals 10. Alright, so if we're going in this direction, it's division. If we're going in this direction, you multiply. Either way, the rate in the middle was 45. Hope that didn't confuse you. Hope we got this down. Let's move on. Alright, write an equation to represent the cost, C, in dollars, to rent a bounce house for about T half days. Alright, this is pretty easy. Actually, we can go right here. We can look at this. Alright, as we know, this is our X, this is our Y. The cost C in C dollars, cost is here, time is here. So we always start off with Y equals, or in this case it's going to be C equals. C equals X, well, T this time, T, whatever T is, times 45, times 45. So that means C equals, denoted correctly, 45T. Correct answer is C equals 45T. What is the cost to rent a bounce house for 2 full days? This is where they're getting us. 2 full days. Remember, they rented at half a day. So the question becomes, how many half days are in 2 full days? This is how you should have annotated and asked yourself the question, how many half days do I have in 2 full days? How would we figure that out? We would do 2 divided by a half to figure out how many halves are in 2 fulls. Keep change flip. 2 over 1 times 2 over 1 equals 4 over 1, which equals 4. Answer is, make sure you understand the question though. You know what gave it away for me? Was the cost, was the dollar sign. So what is the cost of 4 rentals basically? So we said the cost is C equals 45T. Right now we're saying that T is 4. So C equals 45 times 4, which equals 180. Customers who rent a bounce house at the regular rate can rent a second bounce house for 2/3 the regular rate. What is the total cost? Let's wait. Let's do some annotations. 2/3 the regular rate. So we know the regular rate is $45 a half day. So 2/3 of that. But let's go. What is the total cost? Which means you're going to add something. Total means add. total cost to rent 2 bounce houses. We just did that right up here. Hold it. 2 bounce houses for 2 full days using this pricing. So I'm going to do 2 bounce houses. So 1 bounce house is a bounce house for 2 full days. 1 bounce house for 2 full days is this. So 2, adding a second, is 2/3 the price of this. So we need to find 2/3 the price of 180 and then add that to 180. So let's annotate it all right through. 1 bounce house for 2 full days equals 180. The second bounce house is going to be a second. So a second bounce for 2 full days is, let's figure that out. We'd have to do 180 times 2/3. Y'all know how I feel about big fractions. We're going to make this 180 over 1, and then we're going to reduce. 3 goes into 3 once, 3 goes into 1. It goes into 18 6 times. 3 goes into 0 0 times. So 60. 3 goes into 180 60 times. 6 times 2 is 120. 60 times 2 is 120. 1 times 1 is 1. So the additional price is 120. So let's bring it on back. So this is equals 120. So remember this part here, total cost. Your total cost is 180 for the original 2, 120 for the second. We add that up. 0, 0, 8 plus 2 is 10. 1, 2, 3, $300. Give me my money. Explain how I know. This is how I know. Because 1 bounce house for 2 days costs $180. The second bounce house for 2 full days is $120. And then when we add that up, is $300. This plus this equals that. And that's how I know. Alright, let's move on. Nor is painting backdrops for a school play. She paints rectangular backdrops that are 1.5 feet wide and 3 feet tall. Alright, Nor creates an enlarged version of the backdrop by using a scale factor of 2.2. She estimates that it should take her 2.2 times as long, that's cute, as long to paint the enlarged backdrop. Nora says this is because the area of the enlarged rectangle is 2.2 times the area of the original rectangle. Let's see what this part right here. Times the area. So we are looking for area. What's the formula for area, everyone? The area of a rectangle is equal to length times width. So wide is length, Width will be tall for today. Let's draw it up. Not the best drawing in the world. So 3 feet tall and 1.5 feet wide. Alright, so for the area for this rectangle is going to be 3 times 1.5 equals 4.5. So the area for this rectangle is 4.5. So what she's saying is that the area of the enlarged rectangle is 2.2 times the area of the original. I don't know if that's true. That would mean the area, this area here, times 2.2 would equal 9.9. Let's see if that's true. I don't know if I believe that. Alright, so we're going to take 1.5. So we have to scale up 2.2 times. That means our rate became 2.2. 9.9. So, I don't know about that. That would mean if I take this side, 1.5 times 2.2. 1.5 times 2.2 is 3.3. Is that right? 1.5 times 2.2 equals 3.3. Correct. All right. Okay. And then 3 times 2.2 equals 6.6. So I see you guys jumping to conclusions. 3.3 plus 6.6 equals 9.9. But the area of a rectangle is length times width times width times width. 3.3 times 6.6, which equals 21.78. Totally different answer. And if she's going by it being 2.2 times the length of time, this throws that off completely. So do I agree or disagree? I disagree. This is exponentially larger than 4.5. It wouldn't go up by just 2.2. That doesn't match. So what is the area of the enlarged backdrop? It is 21.78 square feet. Got it? Let's go. We're almost done. Which figure appears to be a scale drawing of the figure shown? This is crunched, so I don't even want it blue. I want it red. That's a no. This is stretched. That's a no. This is stretched and something else is just ugly. I don't like it. This is it. Ding. Alright, move on. Alright, the graph shows the amount of grain, G, in pounds consumed by farm goats over T days. The relationship between time and the amount of grain consumed is proportional. Again, they're already telling us that it's proportional. We don't have to figure that out. Alright, what does the point 1 to 14 mean in this situation? This point here. What does this mean? Explain it to me like I'm in 3rd grade. What does 114 mean? Well, 114 means that in 1 day's time, a goat will eat 14 pounds of grain. In 1 day's time, Is it one goat or the goats? The farm goats, plural. The goats eat 14 pounds of grain. That's what that means. Right, an equation to represent the total amount of grain, G, in pounds that the goats consume in T days. Alright, pretty easy. We usually do X and Y, but it's going to be T and G. How do I know? It matches with T is our X. This is our X axis, so that's T. G is this is our Y axis. That's G. Alright. T and G. So in 1 day's time, the goat eats 14 pounds. So this is our Y. We're starting off with G equals T. Anything under T times 14. How do we denote that? G equals 14T. The farmer orders 2,000 pounds of grain. Circle an answer choice in the box to make the statement true. This grain will feed all the goats for a maximum of how many whole days? Whole days. They put that there for a reason. Must mean something. Alright, let's figure this out. We can do this one of two ways. We've been practicing proportions, so we're going to do it that way. The goats eat over 1 day's time. 1 day. The goats eat 14 pounds of feed. So if I get 2,000 pounds of feed, how many days will it take for them to eat it? Right? So 14, the question becomes 14 times what equals 2,000? Or, to figure that out, we would do 2,000 to figure out this rate would be 2,000 divided by 14. Right? This would be our, is it there? Yep, our X and Y. This is X, this is Y. Y divided by X. So 2,000 divided by 14 equals 142. 142.85. Let's do that. What does that even mean? So this here equals 142.85. And some more numbers. So this means if they eat over 1 day, they eat 14 pounds. So over 142 days, they eat 2,000 pounds. Or another way of saying it is they'll eat 2,000 pounds over 142 days. Now here's the whole days part. This is left over. There's still more feed, but it wouldn't feed all the goats for the whole day. Over the whole day. So that means this is our answer, 142. Because it's not enough for the next day. Got it? And good. Explain your answer. 0.85 is not enough for a full next day. All right. This one's a doozy. Let's have fun with this. So, figure A is a scale drawing from an original figure. Alright, That's telling us something. This is figure A, the original figure they're not showing us. That's too small. It was produced by using a scale factor of 2. Produced by using a scale factor of 2. Alright, so that means whatever these scales are, it was doubled. It was a number times 2 to get this side, to get all the sides. So draw figure B in the space provided so that the scale factor from the original figure to B. So from the original to B is 7 over 2, 7 halves. Interesting. Alright, so now first thing we're going to have to do is figure out the original figure, which had a scale factor of 2. Alright, let's get it. So first let's figure out the sides. What is the length of this side? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this side is 12. This is 1, 2, 3, 4, 5, 6, 7, 8. This side is 8. This here is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4. Okay. That's the dimensions of figure A. Let's figure out. It was produced using a scale factor. It was a scale drawing of the original using a scale factor of 2. So that means we multiply it by 2. That means this figure A is twice as big as what figure the original figure was. All right. So we're going to divide all of these by 2 to get the drawing for the original figure. 12 divided by 2, 6. 4 divided by 2, 2. 8 divided by 2, 4. 4 divided by 2 equals 2. 4 divided by 2, 2. 8 divided by 2, 4. Alright, so we're going to draw according to these new green dimensions. The bottom is 4 across. So let's do 1, 2, 3, 4 to match this 4. We're going up by 6. 1, 2, 3, 4, 5, 6. We're going over by 2. 1, 2. Down by 4. 1, 2, 3, 4. Over by 2. 1, 2. Down by 2. 1, 2. Ooh, it's ugly. Try to straighten it up just. I am messing this up. Alright, so this side is 6. This is 4. This is 2. 2, 4, and 2. We're going to label this the original. Alright, now it goes on to say, draw figure B in the space provided so that the scale factor from the original figure to B is 7 to 2. So now we have to do a scale of 7 to 2. Remember, I said to you guys before, the scale is just a rate. So let's set this up. Let's make this bigger so that I could do this over here. So our dimensions are 2, 4, and 6. All right, let's go. So we have a 2, a 4, and a 6. We need a different color. Let's go back to purple. The rate is going to be 2 times 7 over 2. Again, 7 over 2. Let's do that 3 times. Two over 1 times 7 over 2. You know I like to reduce. 2 goes into 2 once, 2 goes into 2 once. This equals 7. Alright, 4 times 7 over 2. 4 over 1 times 7 over 2. Reduce. 2 goes into 2 once. 2 times 7 is 14. And lastly, 6 times 7 over 2. 6 over 1 times 7 over 2 equals 2 goes into 2 once, 3 times. 3 times 7 is 21. So this equals 7, 14, and 21. All right, let's do it. Let's draw this figure B. All right, so that means that the bottom, which was 4 here, what does our 4 equal? 4 is 14, so we have to go 14 across. I'm going to start all the way over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4. Okay. What was 6? 6 was 21, so 21 up. Let's do it. I'm starting from right here. I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Ooh, buddy. Alright, let's try to fill all of that in. Oops. That is not a straight line. Oh no, y'all better leave me alone. I can't use a ruler. Alright, 2. What was 2? 2 was 7. 7 up. Alright. 1, 2, 3, 4, 5, 6, 7. Would that help if I did it on a smaller scale? Scale, get it? Pun intended. Boom. 2 across. 2 is 7. 1, 2, 3, 4, 5, 6, 7. Four is 14. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then these connect over here. Boy, that's an ugly drawing. Alright, so the sides of 2, this is 7. This is 21. This is 4. 4 is 14. 2 is 7. 7. This isn't 7. What are you talking about? Top is 7. And this is figure B. And guys, you are done and done. You did this, study it, you got 100. Good job. See you Monday.